Dear student, I am Nandalal Prajapati from Hindi Madhyamik Vidyalaya, Nasik. Today our topic is from Science Part 1, second chapter, Periodic Classification of Elements. Today our topic is Mendeleev's periodic table. Student, the Russian scientist Dmitry Mendeleev developed the periodic table of elements during the period 1869 to 1872 AD. Mendeleev's periodic table is the most important step in the classification of elements. The Mendeleev considered the fundamental property of elements, namely the atomic mass, as standard arranged 63 elements known at that time in an increasing order of their atomic masses. Statement of Mendeleev's periodic table or law. Property of elements are the periodic function of their atomic masses. They see these tables. Student, here the vertical column in this Mendeleev's periodic table are called groups and the horizontal rows are called periods. Let's see the merits of Mendeleev's periodic table. Merits of Mendeleev's periodic table. Science is progressive. There is a freedom in science to revise the old inference by using more advanced means and method of doing experiment. These characteristics of science are clearly seen in the Mendeleev's periodic table. First point, atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. For example, the previously determined atomic mass of beryllium, that is 14.09, was changed to the correct value 9.4 and beryllium was placed before boron. Second point, Mendeleev kept vacant places in the periodic table for elements not discovered till then. Three of these unknown elements were given the names Eka boron, Eka aluminum, and Eka silicon from the known neighbors, and their atomic masses were indicated as 44, 68, and 72 respectively. Not only this, but their properties were also predicted. Later on, these elements were discovered and named as scandium, gallium, and germanium, respectively. The property of these elements matched well with those predicted by Mendeleev. See table. Due to this success, all connoisseurs about the importance of Mendeleev periodic table and this method of classification of element was accepted immediately. Third, there was no place reserved for noble gases in Mendeleev's original periodic table. However, when noble gases such as helium, neon, and argon were discovered towards the end of 19th century, Mendeleev created the zero group without disturbing the original periodic table in which the noble gases were fitted very well. Then we see demerits of Mendeleev's periodic table. First, the whole number atomic mass of the element, that is cobalt and nickel, is the same. Therefore, there was an ambiguity regarding their sequence in Mendeleev's periodic table. Second, isotopes were discovered long time after Mendeleev's put forth the periodic table, as isotopes have the same chemical properties but different atomic masses. A challenge was posed in placing them in Mendeleev's periodic table. Third, when elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. Fourth, the position of hydrogen. Hydrogen shows similarity with halogens, that is group 7. For example, the molecular formula of hydrogen is H2, while the molecular formulae of fluorine and chlorine are F2 and Cl2 respectively. In the same way, there is a similarity in chemical properties of hydrogen and alkali metal, that is group first. There is a similarity in the molecular formulae of the compound of hydrogen, alkali metals means sodium, potassium, etc. formed with chlorine and oxygen. On considering the above properties, it cannot be decided whether the current position of hydrogen is in the group of alkali metal means first group or in the group of halogen, that is 7 group.